I'm Earl John Falcaza.
I'm Richie Pauline Cosito.
So guys, for today's topic, we divided into 5 chapters with its own subtopics accordingly. As you can see, the flow will start from the general understanding to electrical regulations. We also gave you the luxury to rewatch a certain chapter in just one click. You may refer at the description box below. You may also comment down what you've learned or understand about the topic. So without further ado, let's start!
Hey everyone! Since our topic is about electrical systems, we must first define what is electricity. For starters, electricity is an energy generated through friction, induction, or chemical and radiant effect. In short, it is a movement or motion of the free electron. So where does the electricity comes from? There are 2 types of sources of electricity: storage batteries and generator. Storage batteries stores electricity for the consumption of emergency lightings and other signal type systems. On the other hand, generator has 2 main types also: alternators and the direct current generator. Alternators produces the bulk energy that we use in our houses in general, whereas the direct current generator is the one used in elevators and such systems. Wait, actually, there are other dynamo electric machines we should also remember. First one is motor. Motors convert electrical energy to mechanical energy. Second one is transformer. Transformers convert higher voltage to a lower one, or vice versa. And the last one are rotary convertors. They convert alternating current to the direct current. Now, do you know what are the types of current? Well, there are actually 2 types: alternating and the direct current. Alternating current varies periodically in terms of time rate and direction. It can rise from 0 to its maximum level and goes back to 0 again and rise up to its maximum level again. It just goes on, back and forth. On the other hand, direct current flows at a constant time rate and direction. So, do you know how to measure electricity? Wow! First, before we get into that, we must first get to know our units. And for electrical systems, we have quite a lot of these. So for quantity, we use coulombs and ampere. For electric potential, we use volt. For resistance, we use ohm. And for electric power, we use watts. And lastly, watt hours for energy.
Ohm's Law. Palihog na nakugbasa.
Na-discuss na nato ang units of measurements and Ohm's Law. However, unsaan yun pag-measure sa atong electric consumption sa atong mga balay. So karon atong tanawon kung unsaon yun pag-measure sa atong electric consumption. Let's go out! So guys, mo ni siya ang electrical meter. This is a device nga ga-measure sa atong electric consumption sa mga balay. And as you can see, this meter is not the common type of meter that you will see sa mga balay. So this is a single type or a single phase electronic meter, and ang imo lang makita diya is ang mga dial nga ga-measure sa electric consumption. And for electric consumption, the unit of measurement is kilowatt per hour. So now we're done with regards to the general knowledge of electrical systems. So now, let's proceed to the next report.
So we're going to tackle about building electrical system. Branch circuit. An electrical circuit may be defined as a complete conducting path carrying a current from the source of electricity to and through some device or load and back to the source. The 2-wire circuits, which is the most elementary of all wiring system, consist of the linear wire circuit, which carries the current to the various power, and the grounded wire circuit, which in return carries the circuit back to the source. Series circuit. Series circuit is the one which the components are connected in tandem. All the separate loads in the circuit carry the same equal current, and the resistance R is the sum of the resistances around the circuit.
That's right, and the parallel circuit or the multiple circuit is the one in which the components are so arranged that the current divides between them. In this system, the current that flows through the circuit is the sum of the current that flows to each outlet. This time, we will discuss about the classification of branch circuit. Before telling you the three classification of branch circuit, there are three things defined in the diagram if you base it on the PowerPoint presentation. Firstly is what is a branch circuit. A branch circuit is the portion of an electrical system extending from a final overcurrent device protecting a circuit to the outlets served by the circuit. Next is a distribution panel. A panel for distributing power to other panels or to motors or other heavy power-consuming loads. Controls, distributes, and protects a number of similar branch circuits in any electrical system. Lastly is the low voltage, of or pertaining to a circuit in which alternating current below 50 volts is supplied by a step-down transformer from a normal line voltage used in a residential system to control doorbells, intercoms, heating and cooling systems, and remote lighting fixtures. Low voltage circuits do not require a protective raceway. So the three classifications of branch circuits are the general purpose circuit, appliance circuit, and individual circuit. So the general purpose circuit, which is this line, is a branch circuit that supplies current in a number of outlets for lighting and appliances. The appliance circuit, which is this one, is a branch circuit that supplies current in one or more outlets specifically intended for appliances. Lastly is the individual circuit. This one, and this one. Individual circuit is a branch circuit that supplies current only to a single piece of electrical equipment. Single-phase electrical system. For homes and small commercial buildings, a single-phase electrical system can either be 2-wire or 3-wire and composes of 2 hot legs and a neutral wire. 3-phase electrical system. For industries and large commercial buildings, a 3-phase electrical system is a triple circuit. The lighting and outlet loads are connected between the phase lag and a neutral line, while the machineries and the bigger ones are connected to the phase lag only. So I'm going to show you the parts of the wiring system. You can see here a kilowatt-hour meter or a transformer, which is defined as a passive electrical device that transfers electrical circuit to another or multiple circuits. Next is the circuit breakers. Circuit breaker is an automatically operated electrical switch which is designed to protect an electrical circuit from damage caused by excess current from an overload or short circuit. Under that is the main panel board or the main switchboard. The main switchboard is defined as an assembled unit of electrotechnical components. Connected to circuit breakers are 3 panels: lighting panel, motor panel, and power panel, which we also have a feeder here. So, a lighting panel serves lighting fixtures only. It is a panel for switching or controlling lights and lighting circuits. Next is the motor panel. The motor panel distributes power to motor load. And lastly, the power panel. The power panel is a distribution board that is a component of an electrical supply system that divides electrical power feed into subsidiary circuits while providing a protective fuse for each uncommon enclosure. Connected to them are the lighting outlet, the branch circuit, another power board, a sub-feeder, sub-panel board, a branch circuit, and a convenience outlet.
Now let's go to general circuiting guidelines. Number 1. Branch circuits shall be sufficient to supply a load of 30 watts per square meter in buildings, excluding porches, garage, and basements. Number 2. In all but the smallest installations, connecting lighting, convenience replacements, and appliances and separate circuits. The code requires a minimum of 2 to 20 amperes appliance branch circuit to feed all small appliance outlets in the kitchen, pantry, dining, and family room. Number 3. Convenience replacements in an area shall be wired at least 2 to different circuits so that in case of failure in any one of the circuits, the entire area will not be deprived of power. Number 4. General purpose branch circuits shall be rated at 20 amperes wired with number 12 American wire gauge minimum. Switch legs may be number 14 American wire gauge if the lighting load permits. And lastly, number 5, Limit circuit load for lighting and small appliances on 15 ampere and 20 ampere circuit loads and on 15 and 20 ampere overcurrent devices respectively.
Trivia. A transformer is an electric apparatus designed to convert alternating current from one voltage to another. Right behind me is an illustration of a service entrance. This is a service drop. This is an electric meter, and that is a main panel board or the switchboard, and this is the entrance head. Service entrance is a point of delivery of electricity to a building from a utility company. As you can see, this is the main switchboard, which is for control, protection, and metering the main feeders.
Ikaw, naminaw pa ba ka? Be, basaha daw, be, basaha daw. Sige, basaha. Be, i-post yung video para mabasa tanan. Mana, nabasa na? Be, nabasa na gyud? Sige, basaha outro. Block diagram, a horizontal single-line diagram of the building's electrical system where the components are shown as blocks or rectangles. Single-line diagram when electrical symbols are used. Pahiluman ang iro, B. Saan mo ka, uy? Riser diagram, a vertical line diagram of the major electrical components of the building. Kasamo bang
Right behind me is an emergency system where it provides power and illumination for life safety and protection of property during emergency, such as exit lighting, elevators, fire alarm system, fire pumps, and the likes. On the other hand, this is not directly involved with life safety. It is called the standby system. It includes water and sewage treatment plants and industrial machines for manufacturing processes. This is a battery equipment. This is central storage of batteries mounted in an individual rack, and it is always provided by charging equipment. Engine generator system. These are machines that produces electricity and is composed of three components: the machine and its housing, the fuel storage tank, and the exhaust facilities.
It's Earl, and as you can see, I'm here at my humble abode, and so do you. And in this chapter, we're going to discuss the electrical materials and equipment. Now, join us and let's find together unsang mga electrical materials and equipments na makita sa atong mga individual houses as well as sa mga uban structures. Jomar will start it first. Jomar!
First are conductors. Conductors are materials which allow the free flow of electrons through them. Some examples of conductors are wires, cables, and bus bars. Conductor opacity or conductor current carrying capacity is the maximum operating temperature that its insulation can stand continuously. Types of cables. First, armored cable or type AC is an assembly of insulated conductors enclosed in flexible metal sheath. Metal-clad cable or type MC. One or more conductors individually enclosed in a metallic sheath of interlocking tapes of corrugated tube. Mineral insulated cable or type MI. Assembled conductors insulated with a highly compressed mineral insulation. Non-metallic sheeted cable or type NM or NMC, also known as Romex, is an assembly of two or more conductors having a moisture-resistant, fire-retardant, and non-metallic material outer sheet. Shielded non-metallic sheeted cable or type SNM is an assembly of two or more conductors in an extruded core of moisture-resistant and fire-retardant material covered within an overlapping spiral metal tape. Underground feeder and branch circuit cable or type UF, a moisture-resistant cable used for underground connections. Service entrance cable or type SE or USE are primarily used for service wires. Power and control tray cable or type TC, used for installation in cable trays, raceways, or where supported by wire.
Oh, ikaw, nakasabot pa ba ka sa lasot? Be, yango daw yango kung nakasabot. Smell dayon.
Flat cable assemblies or type FC, an assembly of parallel conductor designed specially for field installation in square structural channels. Flat conductor cable or type FCC, used for appliance or individual branch circuits installed inside floor surfaces. Medium voltage cable or type MV, a single or multi-conductor solid dielectric insulated cable rated at 2000 to 35,000 volts. Second are insulators. Insulators are materials which prevent the flow of electrons through them. Next are conduits. Conduits are circular raceways used to enclose wires and cables and are of metal or plastic PVC. Wow! Conduits are mainly used to protect the enclosed conductors from mechanical injury and chemical damage, to protect people from shock hazards, to provide a system ground path, to protect the surroundings against fire hazard, and lastly to support the conductors. There are three types of steel conduits. The heavy wall steel conduits called rigid steel conduits or RSC with an approximate thickness of 0.117 millimeters. The intermediate metal conduit or IMC with thickness of 0.071 millimeters. And lastly, the thin wall steel conduits named electric metal tubing or EMT. Next are raceways. Raceways are channels or wiring accessories designed for holding wires, cables, or bus bars that are either made of metal, plastic, or any insulating medium. Earl, mao ning first half sa materials and equipments. Unsa pay nadya sa inyo?
Thanks, Jomar. Now, let's continue sa discussion sa electrical materials and equipment, and surprisingly, some of it are visible here sa among house. So, let's go! Outlets and receptacles. Outlet is the point in the wiring system by which the current is taken into to supply the utilization equipment or simply the box, while the receptacles is the wiring device by which the equipment cord is plugged into it. Lighting outlet, intended for a direct connection to a lighting fixture. Convenience outlet, or simply the complete setup, and we also have the receptacle outlets where one or more receptacles are installed. We have here switches, a device for changing the conditions in an electrical circuit. It is rated as 250 volts, 600 volts, or 5 kilovolts, or as per required. Well, switches can be categorized depending on its intensity of usage. We have here normal duty for normal use, heavy duty if frequently interrupted, and light duty if connect loads occasionally. There are also types of switches according to its type of service. There are service switch and power switches. Service switch disconnects all the electric services in the building except the emergency equipments. Power switches can be general purpose switch for general distribution of circuits, and disconnecting or isolating switches for disconnecting or isolating circuits. There are different types of switches depending on its operating mechanism. We have here rotary switch, push button switch, and toggle or tumbler switch. We have here wiring switches that are employed in an interior wiring. For example, the general purpose switches, mga ordinary switches atong mga balay. We also have the three-way switches that can control lamps in two different points. For example, this switch can turn on that light fixture and you can turn it off by that switch over there. We also have the four-way switches that can control the lamp in 3 or more different points. Electrolier or a multi-circuit switches are used to control lights in a multi-lamp fixture. Momentary switches connects to a circuit for only a short duration. And dimmer switches that regulates the intensity of an electric light. We can also categorize switches according to its number of poles and throws. Poles are the number used for making or breaking off a connection, like 2-pole switch and 3-pole switch, and throws are the number of contact points like single throw switch and double throw switch. With an array of switches, there are those special switches, namely time-controlled switches, remote-controlled switches, operated wireless from a distance, air switch, knife switch, float switch, controlled by a conductor floating in the liquid. Mercury switch, especially quiet switch. Key switch or card switch. Wall plates or face plates. It is a covering for switches or outlets and are usually made of metal or phenolic compounds. Now let's tackle the overcurrent circuit protective devices. The main purpose of this is to protect insulation, wiring, switches, and other apparatus from overheating or burning by cutting off the circuit. Example, fuse. It has an alloy link of wire with low temperature inserted to a circuit. Therefore, all current must pass through this metal. Circuit breakers function as a switch and act as a circuit switch. Ground fault circuit interrupters provide ground fault protection. Panel boards, simply the box wherein the protective devices are stored. Switchboards, freestanding assemblies of switches, fuses, or current breakers. Unit substation, an assembly of primary switch, fuse breaker, and etc. and used to supply power from a primary voltage line to any large facility. In this chapter, we're going to discuss the wiring systems. Number 1. Knob and tube wiring consists of a single insulated conductors supported through a porcelain knob and tube, and when wires run through walls, they are inserted through a loom. Number 2. Rigid metal conduit wiring. It is the best and most expensive type of wiring. It is fireproof, moist-proof, it is mechanically strong, and it resists the normal action of cement. Number 3. Flexible metal conduit wiring. Its installation is much easier and quicker, and it comes in length of 25 feet to 250 feet. Number 4. Armored cable wiring consists of rubber or thermoplastic covered wire protected from injury to a certain extent from dampness by 1 or 2 layers of flexible steel armor. Number 5. Surface metal raceway wiring. The wires are supported on a thin sheet steel casing and the insulation is exposed. Number 6. Flat cable assemblies. A structural channel designed to carry 2 to 4 conductors. Number 7. Lighting track. A channel with conductors for 1 to 4 circuits permanently installed in the track that will act as a light-duty plug-in busways. 8. Cable tray or open raceway, a continuous open support for approved cables. Floor raceways. There are 3 types of floor raceways: the underfloor ducts, which are installed beneath or flush with the floor; the cellular metal floor raceway, an integrated structural or electrical system in a cellular metal floor; and the precast cellular concrete. Yes, if na ay floor, na apoy ceiling raceway system, composed of header ducts and distribution ducts separate for power and telephone cabling. Na apoy pre-wired ceiling distribution systems, by which ceiling raceways that are pre-wired in the factory and plugged in where required.
Now we're going to introduce to you guys the electrical symbols that are used in electrical planning. Number 1 is connecting wires. Kilowatt-hour meter, the power panel board, the bulb, duplex receptacle outlet, wiring concealed in wall or ceiling, wiring concealed in floor, wiring turned down, wiring turned on, 3 wires in cable, the telephone jack, television outlet, the branch circuit, the ceiling light outlet, and lastly, the floor duplex receptacle outlet. So those are the 15 electrical symbols. Since we cannot cater all the electrical symbols, we'll be showing you some pictures, and after that, we're going to test you guys if you recognize or identify the electrical symbols that will project on your screen. Now, let's put it to the test, starting from the top.
O sige, pag-answer mo, gikan sa pinakauna. Ansiri na. Ayaw pag-skip-skip. O sige, ansiri.
Homes typically have several kinds of home wiring, including electrical wiring, lighting, and power distribution. For electric power supply, cable is run either overhead and overground to a distribution board in the home. A distribution board or a circuit breaker panel is typically a metal box mounted on a wall of a home. In many homes, the location of the electrical switchboard is on the outside external wall of the garage. So power points or receptacles, plugs, wall sockets needs to be installed throughout the house or in locations where power will be required. In many areas, the installation must be done in compliance with the standards by a licensed or qualified electrician. Power points are typically located where there will be an appliance installed such as telephone, computers, televisions, home theater, security systems, and CCTV systems, and light fittings and switches. So the number of light fittings does depend on the type of light fitting and the lighting requirements in each room. So layout of lighting in their home must consider control of lighting since this affects the wiring. For example, multiple switching is useful for corridors, stairwells, so that light can be turned on and off from two locations. So in layouting the breaker panel, it is important to understand the regulations on where you can install the breaker box. These panels must be easily accessible, thus due to the electrical current flowing through these panels, they must be carefully installed to reduce any type of fire hazards. So in placing your breaker panel, you must be free from any other installations. Number 2, keep it reachable. Place it in a spacious room. Breaker panel should not be located in small locations such as storage, pantries, and bathrooms. Keep the area well lit. Illumination of the area is essential to make it easily to see switches in dim conditions. Those are the things that you have to consider in layouting your light and electrical power.
O ikaw, mata na. Nag-skip ka, wala. Wala? Pag sure diya. Sige, proceed na sa next.
So, in this chapter, we are going to tackle about the electrical regulations under the National Building Code. Right, Earl?
Yes, that's right, Kim. So, listen carefully.
So, let's start. Number 1, the general locational requirements. So, according to the National Building Code, all overhead transmission or distribution lines or systems shall be located and installed following the latest standards of design to not cause visual pollution and in the interest of public safety, convenience, good viewing, and aesthetics. These may be located along alleys or back streets. So the next one is location of poles and clearances of power lines along public roads. So it states here that all poles erected on public roads shall be covered by an approved pole location plan from the municipal engineer. You should also note that poles and transformer supports shall be located not more than 500 millimeters inside the road right-of-way or property line, and also should not obstruct pedestrians. We should also remember that primary lines shall have a minimum vertical clearance of 10 meters from the ground of the pavement when crossing the highway and 7.5 meters from the top of the shoulder or sidewalk. Secondary, neutral and service lines shall have a minimum vertical clearance of 7.5 meters also from the crown of the road pavement.
Oh, so the supporting guys considered as well?
Yes, Earl, that is actually correct. According here, all clearances of supporting structures and their guys and braces is measured from the nearest parts of the objects concerned. So for example, from fire hydrants not less than 5 meters, and from the curbs not less than 150 millimeters measured from the curb away from the roadway.
Okay, so let's proceed to rule number 3. Attachments on and clearances from buildings. Where buildings exceed 15 meters in height, overhead lines shall be arranged where practicable so that a clear space or zone at least 2 meters wide will be left, either adjacent to the building or beginning not over 2.5 meters, to facilitate the rising of ladders where necessary for firefighting. So rule number 4, open supply conductors attached to buildings. In this case, this shall meet the following requirements. Conductors of more than 300 volts to ground shall not be near the surface of the buildings unless they are guarded or made inaccessible. To promote safety to the general public and to employees not authorized to approach conductors, there shall be provided guards to isolate them effectively from accidental.
So the table shows the minimum required clearances of wires from the building surface. So service job conductors passing over roof shall be securely supported by substantial structures. Earl?
Okay, thank you, Kim. So now let's proceed now to rule number 5. Conductors passing by or over the buildings. Minimum clearances. Unguarded or accessible supply conductors carrying voltage in excess of 300 volts may be run either beside or over buildings. You may study the table shown. Conductors or supply of conductors of 300 volts or more shall be properly guarded by grounded conduit or barriers and among others. O ikaw, mata na! Nag-skip ka wala? Wala? Pag sure diya. Sige, proceed na to sa next. Rule number 6. Clearance of service drops. If over roof, conductors shall have a clearance of not less than 2.5 meter from the highest point of roofs. There are 2 exceptions on this rule and you may read it on the screen. Conductors shall have a clearance of not less than 3 meters from the ground or from any form of platform from which they might be reached. Conductors shall have a horizontal clearance of not less than 1 meter from an opening and shall be run at least 500 mm above the top level of the opening. Service drops of communication lines when crossing a street shall have a clearance of not less than 5.5 meter from the crown of the street or sidewalk over which they passes. Service drop of communications line shall have a minimum clearance of 3 meters above ground at its point of attachment to the building or pedestal. Service drop shall be installed 3 meter outward horizontally from the inside of the walls of the pool.
Let's proceed to rule number 7, drill. Wiring methods. Service entrance conductors extending along the exterior or entering buildings or other structures shall be installed in rigid steel conduits or asbestos cement conduits or concrete encased plastic conduits from point of service drop to meter socket and from meter socket to the disconnecting equipment. Abandoned lines no longer required to provide shall be removed. And lastly, power communication lines shall be free from any attachment for antennas, signs, streamers, and the like.
Let's tackle rule number 8 about transformers. All insulated transformers installed outdoors shall be safeguarded. All enclosures may consist of fire-resistant dikes, curved areas or basins, or trenches filled with coarse or crushed stone. Dry-type transformers rated 112 or 1 kVA or less shall have a separation of at least 300 N from combustible materials. Transformers of more than 112 or 1 kVA rating shall be installed in a transformer room and are separated from combustible materials not less than 1.85 meters horizontally and 3.7 meters vertically. Transformers rated more than 35,000 volts shall be installed in a vault. Oil-insulated transformers shall be installed in a vault constructed and specified in this section. However, there are exceptions shown on the screen. Transformers shall be guarded as follows: mechanical protection, caser enclosure, exposed live parts, and voltage warning.
The number 9 provisions for transformer vaults. New buildings requiring an expected load demand of 200 kVA or above shall be provided with a transformer vault. Transformer vault will be readily accessible to qualified personnel for inspection and maintenance and should be well ventilated.
And that's what you said about ventilation. Ventilation should be adequate to prevent the transformer's temperature in excess of the prescribed values. Vaults ventilated by natural circulation of air may have roughly half of the total area of opening required. Combined net of all the ventilating openings shall not be less than 0.006 square meters per kVA of transformer capacity in service. Automatic dampers should be designed and constructed to minimize the possibility of accident closing. Ventilating ducts shall be constructed of fire-resistant materials. Vaults containing more than 100 kVA transformer capacity shall be provided with a drain. Any pipe of duct system forward to the electrical installation should not enter or pass through the transformer vault.
Yes, Jane. For number 11, capacitors. An installation of capacitors in which any single unit contains more than 3 gallons of combustible liquid shall be in a vault. Capacitors shall be protected by physical damage by location, and transformers, which are components of capacitor installations and are used for the purpose of connecting the capacitor to the power circuit, shall be installed in accordance with the PEC section 319. The kilovolt ampere rating shall not be less than with 135% of capacitor rating in kilovolt ampere. For number 12, we have emergency systems. Emergency systems are generally installed in places of assembly where artificial illumination is required, such as buildings subject to occupancy by large numbers of persons, hotels, theaters, sport arenas, hospitals, and similar institutions, and provide powers to such that current interruption will not produce serious hazards. Systems shall be tested periodically in accordance with a schedule acceptable to the authority. Current supply shall be such that in the event of failure of the number supply within the building concerned, emergency lighting and emergency power will be immediately available. A generator set with sufficient capacity will be provided. For hospitals, the transition time from instant of failure of the normal power source of the emergency generator source shall not exceed 10 seconds. Branch circuits intended to supply emergency lighting shall be so installed so to provide service immediately when the normal supply of lighting is interrupted. There shall be an emergency supply source to which the load will be transferred automatically and immediately upon the failure of the normal supply. The switches installed in emergency lighting circuits shall be so arranged that authorized persons have control of emergency lighting.
Right, the emergency switches should be located at the most accessible place to the authorized person.
Yes, Earl. And lastly, were permitted by the authority having jurisdiction in lieu of other methods specified elsewhere in this section, individual unit equipment of emergency illumination shall consist of battery charging, one or more lamps, and a relaying device arranged to energize the lamps automatically upon the failure of normal supply of the building. Unit equipments shall be permanently fixed in place and shall have all writings to each unit installed in accordance with the requirements of any of the writing methods.
So for the effectivity, all primary and secondary supply lines and transformer installations already existing shall comply with the provisions of this rule within 2 years from the effectivity of this rule. Non-compliance with the provisions of this rule shall be subject to the penal provisions of PD 1096. Well, for more detailed and in-depth rules regarding the electrical regulations, you may refer to the National Building Code of the Philippines, or you may read other books, rules, or other provisionaries regarding the electrical system.
Hold me close till I get up. Time is barely on our side. I don't wanna waste what's
Again, we're Group 1. Thank you, and see you.
left.
Bye!